My next step is to take one of these Avery sheets and remove all the labels. And then I'm going to put it through the laser printer and print on the shiny part. See a little shine in there. And I've already done that. And my printer's not very efficient. It produces all kinds of junk on it. The whole page has got a film on it. But these are the outcome, and I'm going to transfer that to the copper. So all we need is a couple of paper towels, an iron on the highest setting, our toner, just got to melt the toner so it'll stick to the copper. Gotta let it cool. So I'm cooling it down so that the plastic will be hard on the copper and the paper will just peel off. A little heat over there. Still warm, but let's see what we got. So you can see I missed a few spots, and touching it up with a pen will make it work. So those are the hazards of doing this kind of a transfer. I do want to try silk screening it, but that'll be a different day, different project. So to move forward on this project, we'll just go ahead and make this one work. So the circuit board came out fairly well. Kind of happy with it, but it would be better if it was silk screened. I did have an error where I had the adjustment resistor connected to the input and not the output. I've corrected that. And I changed the resistor that sets the voltage level. Changed it to a potentiometer of 2K 15 turn. And that works really well. The two transistors for setting the priority controlling, they work well. Now the reason I also need these transistors is for driving, because the current required on the inputs of these can be up to 10 milliamps. So this could require 40 milliamps of current just to flip these relays. And in this case, all four of them on, which it'll never happen, but it only requires less than a milliamp. So this doesn't put a load on the microcontroller. The next thing I had to do was make some jumpers. This is standard silicone hookup wire, which is really nice. Never had this in the past. This is good wire. And I set it up so that it's soldered to the headers that are used in these circuits. And this is some hot glue to keep the strain relief on the wires so they don't break off. And they should be okay. So this is the one to the relays, and the other one is set up for the inputs and the power. Now I have this already connected up to my multimeter, and this is going to plug right there. I put a red mark on the board and a black to match the wires. On this side, I have the black and red. And then this wire here connects up to the relay. I'm going to switch the power on. And it's producing 5 volts. So like before, if I connect the controls to the plus or minus, the minus side, nothing happens. The plus side operates the relay. Turn my light down. Now the dangerous condition is smashing these together and not caring which way it goes, and you can see that the relay will just change the polarity. It will not short out. Putting all 4 relays on at the same time will cause it to blow up. So we're avoiding that possibility, even though it'll be connected to a microcontroller that can take care of that. In the development stage, there could always be a mistake, and if I were to write a 1 to all the input to the this device, it would cause them all to come on. So this helps keep any code errors or anything like that during development safe. It also keeps the drive level low as far as the amount of current required, and it's just safe overall. So I'm going to move on to the next part of this project. So I hope you enjoyed. Please subscribe and hit the like button. Thanks for watching.